point. In this video, we will see that Dirac equation describes the spin 1 by 2 particle. For this, we will find the commutator of H and J, which is equal to 0, and J is equal to L plus S. L is orbital angular momentum and S is spin angular momentum. 1 by 2 summation. First of all, we will find the commutator of H and L, which is equal to commutator of H and L is equal to L1 plus L2 plus L3, and L is equal to R cross P, which is equal to Y P3 minus Z P2 X hat plus Z P1 minus X P3 Y hat plus X P2 minus Y P1 Z hat. First of all, we take commutator of H and L1, which is equal to H and L1 is equal to Y P3 minus Z P2, and H is equal to alpha dot P plus beta M. Is equal to commutator of alpha dot P and Y P3 minus Z P2 plus commutator of beta M and Y P3 minus Z P2, and commutator of this term is equal to 0. So commutator of alpha dot P and Y P3 minus Z P2. Alpha dot P is equal to alpha 1 P1 plus alpha 2 P2 plus alpha 3 P3. So this becomes commutator of alpha 1 P1 plus alpha 2 P2 plus alpha 3 P3 and Y P3 minus Z P2. This is equal to alpha 1 P1 Y P3 minus commutator of alpha 1 P1 and Z P2 plus commutator of alpha 2 P2 and Y P3 minus commutator of alpha 2 P2 minus Z P2 plus commutator of alpha 3 P3 and Y P3 minus commutator of alpha 3 P3 and Z P2. Now we will use two commutator relation. Commutator of A, B and C is equal to commutator of A, C and B plus A commutator of B and C, and A commutator of A and B, C is equal to AB commutator C plus B commutator of A and C. commutator of alpha 1 p1 y p3 is equal to commutator of alpha 1 p1 y p3 plus y commutator of alpha 1 p1 p3. Again we will use this commutator relation, which is equal to commutator of alpha 1 y p1 plus y commutator of alpha 1 p1 p3 plus y commutator of alpha 1 p3 p1 plus alpha 1 commutator of p1 p3 p1 is equal to px, p2 is equal to py, p3 is equal to pz. So commutator of this term is equal to 0, this term is also equal to 0, commutator of this one is also equal to 0, commutator of this term is also equal to 0. So commutator of alpha 1 p1 y p3 is equal to 0. So commutator of this term is equal to 0 and commutator of this term is also equal to 0. Now this commutator is equal to minus iota alpha 2 p3 and commutator of this term is equal to 0. This is also equal to 0. And commutator of this term is equal to iota alpha 3 p2. So commutator of AH and L1 is equal to minus iota alpha 2 p3 minus alpha 3 p2. Similarly, commutator of AH and L2 is equal to iota alpha 1 p3 minus alpha 3 p1, and commutator of AH and L3 is equal to minus iota alpha 1 p2 minus alpha 2 p1. So we combine all three results. So commutator of AH and L is equal to commutator of AH and L1 x hat plus commutator of AH and L2 y hat plus commutator of AH and L3 z hat. This is equal to minus iota alpha 2 p3 minus alpha 3 p2 x hat plus iota alpha 1 p3 minus alpha 3 p1 y hat minus iota alpha 1 p2 minus alpha 2 p1 z hat. This is equal to minus iota alpha cross p. Now we will find the commutator of H and S, which is equal to commutator of alpha dot p plus beta m and 1 by 2 summation. Where summation is polymetrics, sigma 0 0 sigma. Now first of all we find the commutator of H and S1, which is equal to alpha dot P plus beta m and 1 by 2 summation 1, which is equal to commutator of A dot P and 1 by 2 summation plus commutator of beta m 1 by 2 summation 1. Commutator of this term is also equal to 0, so this is equal to commutator of 1 by 2 commutator of alpha dot P and summation. Now we will use this commutator relation, which is equal to 1 by 2 alpha dot P summation 1 minus summation 1 alpha dot P. Alpha dot P is the matrix which is equal to 0 sigma dot P 0 and summation 1 is equal to sigma 1 0 0 sigma 1. So this is equal to 1 by 2 0 sigma dot P 0 sigma 1 0 0 sigma 1 minus 1 by 2 sigma 1 0 0 sigma 1 0 sigma dot P 0. Now we will multiply these two matrices, which is equal to 1 by 2 0 sigma dot P sigma 1 dot P sigma 1 and 0 minus 1 by 2 0 sigma 1 dot P sigma 1 dot P and 0. Which is equal to 1 by 2 0 sigma dot P sigma 1 minus sigma 1 dot P sigma 1 minus sigma 1 dot P and 0. This term is equal to the commutator of sigma dot P and sigma 1. So this becomes commutator of H and S1 is equal to 1 by 2 0 commutator of sigma dot P and sigma 1 commutator of sigma dot P and sigma 1 and 0. Sigma 1 is the Pauli spin matrix, which is equal to 0 1 1 0, and sigma 2 is equal to 0 minus iota 0, and sigma 3 is equal to 1 0 0 minus 1. Now we find the commutator of sigma dot P and sigma 1, which is equal to commutator of sigma 1 P1 plus sigma 2 P2 plus sigma 3 P3 and sigma 1, which is equal to sigma 1 P1 sigma 1 plus commutator of sigma 2 P2 sigma 1 plus sigma commutator of sigma 3 P3 sigma 1. Again we will use this commutator relation, which is equal to sigma 1 P1 plus commutator of P1 sigma 1 plus commutator of sigma 2 sigma 1 P2 plus sigma 2 commutator of P2 and sigma 1 plus commutator of sigma 3 sigma 1 P3 plus sigma 3 commutator of P3 and sigma 1. So commutator of this term is also equal to 0. 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 Since commutator of sigma 2 and sigma 1 is equal to minus 2 iota sigma 3. So this term become minus 2 iota sigma 3 P2 plus commutator of this term is equal to 2 iota sigma 2 P3. Similarly, now put this commutator relation in this equation, which is equal to commutator of H and S1 is equal to 1 by 2 0 2 iota sigma 2 P3 minus sigma 3 P2 2 iota sigma 2 P3 minus sigma 3 P2 and 0, which is equal to 0 sigma 2 P3 minus sigma 3 P2 sigma 2 P3 minus sigma 3 P2 0, and we take iota common, which is equal to iota 0 sigma 2 P3 sigma 2 P3 0 minus iota 0 P2 sigma 3 P2 0, this is equal to iota P3 0 sigma 2 0 minus iota P2 0 sigma 3 0, which is equal to iota alpha 2 P3 minus iota alpha 3 P2. Similarly, commutator of H and S2 is equal to minus iota alpha 1 P3 minus alpha 3 P1, and commutator of H and S3 is equal to iota alpha 1 P2 minus alpha 2 P1. So commutator of H and S is equal to commutator of H and S1 x prime plus commutator of H and S2 y hat plus commutator of H and S3 z hat, which is equal to commutator of H and S is equal to iota alpha 2 p3 minus alpha 3 p2 x hat minus iota alpha 1 p3 minus alpha 3 p1 y hat plus iota alpha 1 p2 minus alpha 2 p1 hat, which is equal to iota alpha cross p. Now commutator of H and J, which is equal to commutator of H and L plus S, which is equal to commutator of H and L plus commutator of H and S. Sigma 2 P3 sigma 2 P3 0 minus iota 0 P2 sigma 3 P2 0, which is equal to iota P3 0 sigma 2 0 minus iota P2 0 sigma 3 0, which is equal to iota alpha 2 P3 minus iota alpha 3 P2. Similarly, commutator of H and S2 is equal to minus iota alpha 1 P3 minus alpha 3 P1, and commutator of H and S3 is equal to iota alpha 1 P2 minus alpha 2 P1. So commutator of H and S is equal to commutator of H and S1 x prime plus commutator of H and S2 y hat plus commutator of H and S3 z hat, which is equal to commutator of H and S is equal to iota alpha 2 P3 minus alpha 3 P2 x hat minus iota alpha 1 P3 minus alpha 3 P1 y hat plus iota alpha 1 P2 minus alpha 2 P1 hat, which is equal to iota alpha cross P. Now commutator of H and J, which is equal to commutator of H and L plus S, which is equal to commutator of H and L plus commutator of H and S, which is equal to minus iota alpha cross P plus iota alpha cross P, which is equal to 0. Hence commutator of H and J is equal to 0. So Dirac equation which is equal to minus iota alpha cross P plus iota alpha cross P, which is equal to 0. Hence commutator of H and J is equal to 0. So Dirac equation describes spin 1 by 2 particle. So Dirac equation describes spin 1 by 2 particle.